Prove that the sequence un defined by u1 equals to root 7, un plus 1 equals to root over 7 plus un for all n greater than equals to 1 sequence converges to the positive root of the equation x square minus x minus 7 equals to 0. Or prove that the sequence this root 7 root over 7 plus root 7 dot converges to the positive root of the equation x square minus x minus 7 equals to 0. Now see that first term u1 root 7. Now from here put n equals to 1. Then u2 equals to root over 7 plus u1. That means here now we put the value of u1. So 7 plus root 7. Similarly u3 equals to root over 7 plus u2 equals to root over 7 plus u2 means root over 7 plus root 7. So this and these two questions are equivalent. Same question. So first here un plus 1 square equals to root 7 plus un. So we can write here from this un square equals to 7 plus un minus 1. Therefore un plus 1 square minus un square equals to un minus 1. And this implies un plus 1 plus un into un plus 1 minus un equals to un minus un minus 1. So since un greater than 0 for all n, each term positive, so this is always positive. So un plus 1 minus un, we do not know that this sequence un is monotonically increasing or decreasing. So un plus 1 minus un greater than or less than 0 according as un minus un minus 1 greater than or less than 0, because this is always positive since un greater than 0 for all n. Now therefore un plus 1 greater than or less than un according as un greater than or less than un minus 1. So now u1 equals to root 7. This is strictly less than root 7 plus root over 7 plus root 7, because we add root 7 here, equals to this is u2. Therefore u2 greater than u1. This implies, now see that un plus 1 greater than or less than un according as un greater than or less than un minus 1. Now here put n equals to 2, u2 greater than u1. So u2 plus 1, u3 greater than u2 implies u3 greater than u2, and similarly u4 greater than u3 and so on. Therefore u1 less than u2 less than u3 less than u4 less than dot dot dot. So sequence un is monotonically increasing, strictly monotonically increasing. But since sequence un is monotonically increasing, strictly monotonically increasing, therefore un plus 1 greater than un for all n. un plus 1 greater than un for all n, since sequence un is monotonically increasing. Now implies un plus 1 square greater than un square for all n. Now un plus 1 square equals to 7 plus un strictly greater than un square for all n. From this implies un square minus un minus 7 less than 0 for all n. We can write it as un minus alpha to un minus beta less than 0 for all n. We name it 1, where alpha and beta are roots of the equation x square minus x minus 7 equal to 0. We can write this. We put un equals to x. Similarly, we write here un minus alpha into un minus beta. This is written as this. Now, alpha and beta roots of the equation this. So, alpha beta equals to minus 7 less than 0. We know if fx equals to a0 plus a1 a0 x square plus a1x plus a2 be a polynomial of degree 2, then where a0, a1, a2 are real or complex coefficients. Then the equation fx equals to 0 has two roots, at most two roots. Let alpha and beta be the roots of the equation fx equals to 0. Then alpha plus beta equals to relation between roots and coefficient. Alpha plus beta, sum of the roots equal to minus a1 by a0, and product of roots alpha beta equals to a2 by a0. This is a0. So here x square minus x minus 7 equals to 0, and alpha beta roots. So here a0 equals to 1, a1 equals to minus 1, a2 equals to minus 7. So alpha beta product of roots equals to a2 means minus 7 by a0 means 1 equals to minus 7. So alpha beta equals to minus 7. Therefore, one of the roots alpha and beta will be negative. Let alpha be negative. Then un minus alpha must be positive, since this is for all n. Since un greater than 0 for all n, is term positive, so positive minus of alpha 2 is negative, so minus minus a positive, so this term will be positive greater than 0. Suppose two numbers x and y, x is positive, y is negative, x equals to 3, y equals to minus 2, then x minus y equals to 3 minus of minus 2 equals to 3 plus 2 equals to 5 greater than 0. So this will be greater than 0 for all n. From 1, un minus alpha is greater than 0 for all n. So from this un minus beta strictly less than 0 for all n. Therefore even minus beta from 1 strictly less than 0 for all n implies even less than beta for all n. This shows that the sequence even is bounded above. Also, sequence even is monotonically increasing. Therefore, sequence even is convergent, because if a sequence is monotonically increasing and bounded above, then the sequence is convergent. Let limit n tends to infinity un equals to L. Then un plus 1 square equals to 7 plus un implies limit n tends to infinity un plus 1 square equals to limit n tends to infinity 7 plus un implies limit n tends to infinity un plus 1 square equals to 7 plus limit n tends to infinity un implies, now limit n tends to infinity un equals to L, so we can write also limit n tends to infinity un plus 1 equals to L. Therefore, this is L square equals to 7 plus L implies L square minus L minus 7 equals to 0. We can write this as L minus alpha to L minus beta by similarly equals to 0. Now since each term of sequence even is positive and we choose alpha less than 0, therefore each term of sequence is positive, so sequence even cannot converge to a negative value, that is, so L does not equal to alpha, so we are left with L minus beta equals to 0, that is, hence L equals to beta, that is, sequence even converges. We assume that alpha less than 0 and beta is greater than 0. So, and alpha beta roots of the equation x square minus x minus 7 equals to 0. So, sequence even converges to the positive root of the equation x square minus x minus 7 equals to 0. So, we prove this. Sequence even converges to the positive root of the equation x square minus x minus 7 equals to 0. Proved. If you like this video, please share and subscribe.